Thank you for the opportunity to be here and to talk to this awesome community. So let's see what we have today. So essentially, we will talk about BigQuery. Who is an SQL developer in the room? Because I want to question us. OK, who is a developer in the room? OK, much more hands. Then it's understandable. Good. So I will talk about products, and these products are on Google Cloud Platform, essentially, and we use it for large data lake, analytics, reports, and so on. We had large builds, and actually we have ways to reduce those builds using techniques, and I'm going to showcase you several today. So about me, I'm from Romania, actually Hungarian. And I may have answered some of your questions on Stack Overflow because I built out a lot of reputation answering questions about everything, cloud, Android, and PHP as well. I'm appointed GD since 2016 on cloud, and you will find the slides and Twitter under Marton Kodok on SlideShare as well. This talk also has an article available on Medium, so eventually if you want to look up the queries that I'm demoing, later you will have the option to look it up much more deeper in your ways to do that. So our agenda is really packed, and hopefully I will end up to show everything for you. We will look at a BigQuery building report. We will see what is BI engine. That's, let's say, a memory accelerator. We are going to use the job billing stats to see where we are today and what we can optimize next in the process. And then we will see cloud workflows, which is relatively, let's say, a new serverless product on the Google Cloud Platform, to orchestrate based on the daily pattern, the accelerator, in order to see it good and better and optimized in a way to do that. Good. So whenever we are looking at a BigQuery report, we see it's constantly growing. So hopefully that's for you as well, because in BigQuery, we store a lot of data every month, and for everyone is constantly building up and so on. Who can tell me what are those dips at the beginning of each month? Because that's a thing that I need to say. So essentially, each month, BigQuery offers 1 terabyte of free. And that's actually every month on the BigQuery report. That's the 1 terabyte free dip that you are seeing in the report as well. Now, this is probably a BigQuery report on a study project, and we want to go to this. And as you say, it's a two-phase process. So first of all, we are activating the BI engine. It's not effective. We will discuss why. And then after we introduce orchestration and effectiveness, we will see how we can reduce the BigQuery bills as well. For this, we are going to get to a point where cloud workflows will be used as an automation, as an orchestrator service, essentially based on the information schema jobs, or some of you might have audit logs enabled in BigQuery. That's the source of information. Based on that, we do some calculations, and we resize the BI engine automatically, to say so. So let's go now deep dive into the session. So what is BI engine? First of all, BI engine is a fast in-memory analysis service, part of the Google Cloud Platform, that integrates out of the box. So we will talk about this out of the box thing, and it integrates with all the products that access BigQuery, like Datastudio, Looker, Tableau, Power BI, and all the other things. If we need to have an architecture, Google represents this architecture. I'm a software developer from Romania, so I'm not a Google developer, so I've taken this picture from their website. It's a vectorized runtime. They cache all the information, and they serve it. It could be like a feature of BigQuery, like a Memcache accelerator or a Redis accelerator, but it's delivered for you out of the box, and essentially without a code change. So I keep mentioning out of the box, and I want to showcase you why is that out of the box. So it's a plugin, it's a managed service. You don't need a sysadmin to activate it. You just actually turn it on, and you set the capacity in gigabytes, and also increments in bytes, because not just 1, 2, 3 gigabytes, you can also use bytes as well as an increments as well. That's a good logic also to have it that. The allocation is at project level. So BigQuery and Google Cloud Platform has this complex schema of having organization, folders, projects, analytics, reporting. So this is only on the, let's say, on the billing level. So it's important to understand that it's on the billing level. So you may need to activate BI Engine for a big set of sub-projects, to say so, because billing sits on the top, and you may have different projects underneath. Cache is only columns and partitions that are queried or scanned. So it's important to understand that it doesn't cache the whole table. Well, that's natural, because BigQuery tables are large, like 5 terabytes, petabytes, and caching them is out of the scope. So it only caches the partitions and the queries that you scan, and can use without any changes. And I confirm you 100%, you don't need to do any code change. You don't need to actually change anything in your SQL or how do you integrate with BigQuery, because when you turn on BI Engine, it's automatically hooked in the system. In an architecture way of point, if there would be a balancer, because you know everything is rooted architecture in a balancer, this could be part of the balancer itself, if I need to create an example. So you can animate Monday, go to your office, ask who has the permission to activate BI Engine, verify it, and turn it on with 1 gigabyte, 2, and see if it's effective, and so on, with my queries that I will demo. Well, because we want to optimize costs, let's discuss a bit. I won't discuss the whole slide. Essentially, $5 or euro, whatever is, for 1 terabyte of costs. And we want to reduce this by introducing other costs. So actually, we are adding cost to the system, but with that, with the memory accelerator, we get reduction of BigQuery cost. That's the business logic, that's the math we are going to follow. Essentially, this is $30 for a month. It's affordable, and even with 1 to 2 gigabytes, you will do magic if you don't have BI Engine enabled. Good. Now the part is that we know some bits of this information. Let's see how we put together. So the aim is to dynamically adjust the size of BI Engine to get the lowest combined cost of BigQuery and BI Engine. So introducing cost, lowering cost, and the combination should be the combined cost. There are some challenges here, and one of the challenges is to obtain the cost of your on-demand BigQuery usage. What this on-demand means? On-demand means that some of your organization companies might be on a flat rate with BigQuery, because there are ways to go around $1,700 above. There is a flat rate that actually gets much more benefits out of it. But if you have, let's say, in the 2,000, 3,000 segment of bills, you could get optimization as well. Also, if you go like 5,000, you can reduce under the 1,000 the bill as well, so it could be effective as well, and you should not eventually go to the reservations of BigQuery slots as well. We are going to see how to drive the capacity automation up and down and monitor the settings. Well, there are 2 prerequisites. Actually, it's an OR logic in here, so not 2. Formerly, we had to work with audit logs, and that had to be turned on. Still, it's a good thing, because audit logs logs everything what's happening in your cloud projects, and you have it in your history as well. You could turn it on. It will be synced into BigQuery. It will be a modi cost for your company. And nowadays, we have access to information schema. And information schema will help us to actually see which jobs, because in BigQuery, every query is called a job, which jobs consume what amount of bytes and what kind of cost is that. Information schema is not a prerequisite because it's available to you. You just need to have the permission to access it. So there is a separate role to run a select query and a separate role to run a select query from information schema, because that's, let's say, administrative rights as well. So straight to the problem. I have a query which is using the from syntax of information schema. There is a view available, jobs by project. It's available to everyone. The trick here is that there is an additional syntax that developers may not be used to, so you need to have your project ID and a region added to the string of the table. Initially, I didn't get it as well. I tried to use my project, my dataset, and didn't work, so the suffix of the region is needed to be added, and often people forget this. This is only particularly for the information schema. And I'm actually reading creation time. I'm reading total bytes processed and total bytes built. And essentially, this 5 is the €5 or $5 that the cost of this query is. The rest is math of it. And I'm reading for 1 day, like 3rd October. This produces a table where I have processed and build bytes. Essentially, these are the same right now because there is no optimization in place. And of course, people ask me in the end of the session, you can get the query itself, but I didn't put in my select statement. So you could, for example, use this trick to actually find the topmost consuming queries of you and look at the select and optimize it out of this concept for it. Good. A moment for the cameras to take the photo. Good. Next, we are going to the second query, which the first one is a with statement with the previous thing that I mentioned. The second one is actually an aggregation by hour, and it adds saving as a percentage. I will jump it because it's in the article, the query itself. I added 2 more columns, and now the data is built, is grouped by 4 hours. So essentially, the trick is that I've got 75% reduction during that hour by using BI Engine. So essentially, even if you don't use any orchestration service and you just turn on BI Engine with 1 gigabyte or 2 gigabytes, you will be able to see these numbers, let's say, in the next hour, because turning out is 5 minutes. We wait 1 hour, and you will see how effective it is, and so on. And now, as you may approach that, since we have available this information, we can go and think much more ways to actually improve these numbers. Because initially, first 75% is let's say, it's too good to be true. So usually you get 5%, 10%, and you need to do some after work for it. And let's see what those are. So remember the first chart, when I turned on BI Engine, it wasn't effective. So we are in that point that it's not yet effective, and we need to make it effective. This is the chart, and so on. So 2 reasons: BI Engine capacity might be too small, or BigQuery queries are too complex. And let's see why. First of all, BI Engine doesn't accelerate all the BigQuery queries. That's acceptable. And the good luck is that in the job statistics, there is a table, there is a JSON that actually tells us if a single query was accelerated or not by BigQuery. There are 3 statuses here, like disabled, partial, and full. Essentially, full means that the whole query was optimized, so it's fast. Partial is the one where you could improve further, and disabled is the one that you need to take care of that. But not all the disabled queries can be optimized as well. So we will see hints to what these are. Now, usually the developers see this nice information of table, like, okay, disabled partial, but I want hands-on information to it. So if you look at the single job, either using the command line, this way I'm using the command line, you will have in the JSON is really big, so I put out only 5 rows off of it. You will see the hints for the query itself that you may want to optimize. And it's up to your comprehension and up to your colleagues' comprehension to rethink that query in order to remove the limitation that BI Engine tells you that. Sometimes the queries can be reorganized, can be put in steps, can be used other techniques to it, so it's up to the comprehension of the business logic to rewrite the queries itself. Also, this is available in the information schema, and that's actually the source of information for you. You have the reason itself, so you have this struct, BI engine statistics, this is a struct, and outputs you different columns. And it exactly tells you what kind of information is here. Also, the query itself can be added to this table, so you will have the query visible as well. So query output to destination table is not supported. There is no optimization to take place here, because that's actually one trick I will follow next in the slide, where you get a flat table created in a mini table, let's say, and that is an intermediary step in your analytics and reporting logics. Analytic function is incompatible with other operators, or inputs are too large. This is understandable. You may look on Stack Overflow for tricks how to rewrite some of the queries and so on. No input table reading subquery, which is, let's say, a static query. It could be like static query. There is no something to optimize. Joining with a partition table is not supported. So actually names you which table is the culprit in your query itself, and you may want to reduce or take out that query to use without the effect that's mentioning, and unsupported join types detected. So this is hints for you in order to, and there are more hints available in order to make and change the queries itself. Essentially, people ask me that what is our level of rewrite of queries? Well, it's only 5%. So the whole optimization and the whole topic that I'm covering today is really effective by just turning on BI engine. Often you get, like, I had a query that consumed 3.3 euros on every runtime. And I was looking into, because every time it was just too big, the queries. Good. So to have effective BI engine acceleration, we need to investigate queries to see which is disabled partial for BI engine acceleration. We can rewrite queries to be better in the optimizer. We can use materialized views to join and flatten data to optimize their structure for BI engine. A moment about this. So essentially, when you architect the BigQuery dataset, you have a big raw table, which, let's say, unstructured data is streamed or imported to that. You don't touch that, only import there. There is a second layer of information where you semi-structure some of the data into columns and essentially use that as a second source of truth for your data. And the third one, I would say, it's scoped information for the business case. So even using the second level, I create another table that has my partitioning logic. It has for the task, for the business logic, the partitioning logic. It has the clustering for that particular business logic. And even if the data is in 3 places or many places, effectively it's cheap, because storing a petabyte is only $20, and storing a terabyte is $20. Storing a petabyte is 20,000 euros, and even a petabyte. Oh, that's data for a database. It's a big stuff, and for a company, it's not that problematic if they have that many data. What's the trick with materialized views? These are very optimized by the BigQuery team, and essentially it provides you a scheduler-based views. So it, in the background, automatically refreshes itself. It's not real time, but you have a 50 minutes window where you have the most near real-time data in it, and you don't need to engineer any work on top of it. It's a good shortcut and a good pit stop for a developer to turn out materialized views, but always keep in mind that you can set the scheduling recurrence for it. The default is too aggressive, and you may need to lower it, because in the background, every time it runs the BigQuery in order to produce the material views to recreate it and so on. So essentially, you may need to adjust the default one to be, let's say, 1 hour, 2 hours, 6 hours, whatever the business drives for you. Going further, if you don't want to use materialized views, and sometimes I would say it's a complicated process and the benefits are different, and materialized views are not always available, for example, for external tables, for complex analytics queries, you need to use temporary tables. By temporary tables, don't think the regular SQL create temp tables, so it's nothing like that. I would say it's a syntax of create or replace. So essentially, you as a developer, you not soft shard, but you soft recreate the tables based on a strict scheduler. That could be even a granulate of 1 minute, it could be 5, it could be 15, it could be 1 hour, and so on. And why it's important? First of all, you may know that database caching is effective when the underlying table doesn't change. If there is constant information fed to the table, the cache is invalidated because it might have a different syntax. But if the table is fixed for 5 minutes, then the query cache is effective as well. And I'm not talking about BI engine, just the simple query cache as well. We use these short-lived tables a lot for Datastudio. That's really effective on Datastudio. The dashboard loads really fast. And we have the Datastudio touching only specific tables created for Datastudio, even if there is other levels of information to store the business data. And increase the size of the BI engine reservation until effective use. So this is also business logic that they will discuss next. And essentially, this is accomplished with cloud workflows to automate based on the workload during the day. So that's actually the most important fact of it. Good. A bit of hints, because I always approached after the talk in the lobby to show them queries, because people want queries. And I selected here 2 cases which we frequently use. First of all, we use a scheduler, as I mentioned earlier, to recreate a table every 5 minutes and so on. So business team, and let's say the dashboard owners or whoever used the dashboard in the Datastudio is aware that this table is not real time. It doesn't have the data from 10 seconds ago. And we eventually put on the Datastudio a label that last data is from 25 minutes ago and so on. So they are informed on the screen that what they are looking for is 20 minutes ago. And we use a dedicated table for scope. So it means that it doesn't touch the big tables. It's only for that report, and it's being recreated for every use of it. And it's very effective for this as a cost component. And also Datastudio is really fast for it. And of course, every query is different. Every table, every use case is different. And in BigQuery, clustering is a thing that effectively lets you to reduce a lot the scanned bytes in the query. And you may know that there are 4 columns that you can use in clustering. And if you have different queries from the same table, you may choose for primary clustering, but you may actually create separate tables, even either material views, either temporary tables, but you can choose different clustering there. And that's really effective for us, for the task as well, because, for example, let's go back to the Datastudio report. There are filters there. The operator can filter by country, filter by day, filter by different aspects. And that actually helps you to clustering. What this is clustering about? So it's like the first one is a large box, the second column is a smaller box, and so on. So box, 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 box. Whatever you are querying there, it's lower, lower, lower in the access of information. Good. Next one, and this is a tricky one. It took me 2 weeks to figure out. Essentially, in BigQuery, you always work with append-only tables. What that means? For one session ID or record ID, you have 20 or 50 lines as the data is being updated. Like a user profile, every time it's updated, you get a new line in it, and you always need to get the last row out of it. So essentially, a lot of companies, when they create this kind of table, this is fragment in BigQuery, they always create next to a view with the suffix host last something I've seen, and that way they can always access the last profile data of a user. Well, with material views, that's a bit of 2-step, because material views always need this, let's say, group by thing, and for that you have an array that you need to use, and you will end up with an array in the row itself. But even if you have used limit 1, you know that array has only one cell. So essentially, this one is a material views, but on top of that material views, you can, for example, this is using the second query uses the first data. You can create a regular view and selecting only safe offset. The safe is needed because sometimes the first cell is missing, so it will cause null pointers errors. You will actually flatten the one cell array into one column. And this, it took me 2 weeks to figure out because it was not available in the manual. Now it's available in Stack Overflow as an answer. And this is a really good technique to actually work with append-only tables and to figure out flattening them to be much more easy syntax for a developer. Good, and the final part is to introduce cloud workflows. Who uses serverless function containers in the room? Good, not many hands. Oh, serverless, you need to use serverless. Around 5 hands. Okay, so let me introduce to you then that in the serverless world, they are not just functions as a service, not just containers as a service, they are workflows as a service as well. And the workflows is a syntax of YAML, so you don't need to use either a coding language, you just reflect the workflow logic using YAML. The benefits are that you don't need to update your functions, even if I name the workflow as a function, like every 2 years, because just imagine the Node.js developer, every 2 years a new major version is coming out, they need to redeploy and so on. YAML is still the same as we know, so even if you deploy your recipe, it stays there 5, 10 years until you deploy, and there are lots of recipes available. And Cloud Workflows is a step engine. It's also managed service in the Google Cloud Platform. And essentially, it lets you to run a workflow with steps, or you can run a tree of workflows. You can run one after the other, or you can parallelize steps out of it. So it's a really versatile engine. If you are more into this, look up my profile, because I have another talk, not at this conference, about cloud workflows. Actually, yesterday in this room, if Gilam had a presentation about cloud workflows. I just remember that yesterday it was introduced to you. Look up for the conferences, previous sessions, because cloud workflow is an amazing tool for it. It can automate anything which is reachable by HTTP, and that means that the entire internet. So it's a product on Google Cloud, but it doesn't automate just Google Cloud. It automates everything. We used to automate SendGrid to send emails. We used to automate Bitly for the link shorteners side of things. So outside services, with anything which is reachable by HTTP. Good. So what's in this scheme? Well, essentially, the cloud workflow, it could kick in, let's say, every hour, run a query using the information schema job to calculate, let's say, the previous state, the last 2 previous states, if the capacity movement was good or ineffective, and based on that, suggest a new one in order to make the size differently. How this can be easily do with the previous shown queries, you just need to take, let's say, the 1 hour, 2 hour, and compare it if it's in good direction or in bad direction, and then you set the 3rd hour capacity. Essentially, this is the block of YAML that changes the reservation size. It's not BigQuery, running the SQL query is not on the screen. This is only the step that runs the BigQuery reservation, the BI engine reservation. In a nutshell, workflow has steps. So you have here 3 steps, 1, 2, and 3, these items. Here we initialize the project ID. Here we set the capacity size, and here we have a return. So this is a workflow has 3 steps. Essentially, you have a syntax of HTTP patch that could be get post for other type of automation in the cloud workflows. You have an URL. The URL is taken from the manual itself, and it's concatenated with location, and essentially there is this endpoint BI reservation. there is a query parameter that you need to add update mask and 2 gigabytes expressed in bytes here to add it. Fractional bytes can be used as well, not just entirely gigabytes as well. And often I get a question that how do you delete it? Well, there is no other API call to delete it, so eventually you need to use this same patch query in order to use 0 as a disabling BI engine as well. Also, this was not part of the manual, and I had to ask the BI engine team to understand better. Good. Okay, so we are back to this screen. So effectively, you have a cloud workflow engine that drives based on last 2 data, the new data, and based on that, you will get a pattern of moving up and down. Essentially, based on that, you will have a system that will tell you the saving percentage and so on. Essentially, you will compare the vector that you have created if it's going in good direction or not. Well, I already talked about this, reads the output of the effective build and processed. Yeah, so I didn't expressly tell you that in BigQuery, why is possible all this? It has 2 different columns for processed bytes, which is the query itself, and a different column for build bytes. And if the 2 are different, it means that there is an acceleration on the process itself. So that's the true hidden source of information to the logic for this kind of automation. You could have a map. I've been asked that, okay, I don't want to go with orchestration and so on. You could have a map like between 9 and 5. People use more the dashboards and the reporting services, so you could have a map to increase with different steps of it. Good. The last one is actually, there is BigQuery ML. And BigQuery machine learning already added like 25 objectives of machine learning. So look it up. I have a presentation about BigQuery ML as well on my website and on SlideShare. What capabilities have BigQuery ML? One of the type of things is forecast. And with forecast, you could, for example, have a machine learning logic forecasting the BI engine size based on the information schema jobs aggregated per hour type of machine learning thing out of BigQuery. It sounds complicated, but it's not like that. You need to first get from schema the flat table. You need to create from that view a table for the data organized in a way that you have for the forecasting engine. Then you run another SQL, which is create model. In BigQuery, you are able to create the model itself using just SQL language. Create model, and once you have the model itself, it's trained based on your historical data. And the cloud workflow itself could run every hour, and based on the forecast, you have a ML predict function that you can access it. Based on the forecast, it can predict the next BI engine ad. Yeah, so I see smiling people, so some of you will use this because it's not that hard to put in effect, and it's really effective for that. And I need to tell that forecasting is not about stocks and the Bitcoin and so on, so you can use for much more intelligent thing for that. Good. Of course, don't go big. So there is a rationale until the savings are working out. And you need to have that. You have the map because you know exactly 1 gigabyte of reservation, what is the cost of the reservation. You have what is the cost of the BigQuery, and you can put that into your SQL questions as queries, that information. So in the end, either optimizing by rewriting some of your queries or using automation, you will get a really good reduction. Now the free here as a 1 terabyte. This red one is the BI engine, so effectively you see that there is a big increase of BI engine usage. This is like not big, but it's visible. And on this project, the automation it's not fluctuating, to say so. Of course, also the billing report is per day, so it's really hard to have different days. I expected to have, for example, weekends to be lower in the reservation, but apparently didn't pick out. So I don't know, either we have the system so many queries in the application that it's the personnel itself doesn't separate in the weekend itself. Good. Other aspects. You may have used Datastudio. Now they renamed this since last week because there was the Cloud Next, so it's called now Looker Datastudio. You have this icon, which often people ask in different chats, that it says disabled. I mean, it says acceleration disabled, and how do I enable that thing on feed? Well, if you just enable BI Engine, you will have the icon telling you that it's accelerated by BigQuery BI Engine without rewriting anything. Not for everything, because there are complex queries which won't be possible, usually those that scan more than 500 partitions. And for that, you need to use the create Materialized Views or create tables in order to create dedicated Datastudio templates for it. And of course, I didn't mention so far, because I was talking at the developers, that turning out automation is faster as well. So not just cost-wise is a good thing, but also it gives you faster. And on Datastudio, you will see that the dashboard doesn't load in 20 seconds. It might load in 3-4 seconds, and so on. At least what's above the fold. Depends on the filters, because I have this project where I have activated BI Engine. I tailor it to the default view, but as soon as they add filters to it, it's going into non-effective one, because I cannot create and anticipate all the filters that the operators use. So at some point, when they start to use the filters, they get back to the 20-second or slow loading aspect of the Datastudio. Just as a lesson that we have already learned, and we need to explain to the people that if they touch a complex filter, they need to wait for the query itself. In cloud monitoring, you can plot using this address the used bytes and total bytes of BI Engine. This is a good feedback to actually see how is working out your capacity reservation. And you will be amazed that it's always at the top of the floor, but that's how accelerators work. So if there is memory, they put trash in it. So don't expect to be half full. Every time it will be full, and that should not drive you the logic. So don't make that mistake that you use, like how full is this, and use that in the cloud workflow automation. Don't do that, because accelerators are like throw everything in and then later they evict the content out of it. So watch out what you use for it. It was a short moment. It was rescaled to 5 gigabytes, and then later it was rescaled because it wasn't effective for that operation. Well, I have an article on Medium about this, so you could check it out. It's based on audit logs. Now you actually get a premiere using the information schema jobs. It's much more simpler syntax, available recently on BigQuery. With audit logs, it was a longer process. The logics of the query are still there. And conclusions. So, easy out-of-the-box way. Literally, you don't need to modify a code at all. Just by turning on BI Engine, you have leverage information schema stats to see underperforming queries and try to optimize them. So you can either optimize them for the reduction or for the faster processing. You can automate the write capacity by using cloud workflows, and you save precious development time, lower bills, faster queries for your operation as well. This concluded my presentation for today. If you have any questions, let me know. And while there are some questions, I advertise one of my open source contributions to VS Code. I created a little plugin that sits in the status bar, and it lets me to switch which GCP project I'm working on. I'm the author, please edit. It's really valuable information for development team for that. I was Marton, Hungarian from Romania. It was nice to be first time here, and hopefully we will meet with different topics and so on. I am available on the back of the corridor if there are no immediate questions right now.
Thank you very much.